All right, to recap. Sorry, because I have to recap for 6 hours. Degree in numerator is 2. Degree in denominator is 1. No horizontal asymptote. Vertical asymptote we got by setting the denominator equal to 0. Now we're trying to find x-intercepts. We can't factor this, so we're going to use quadratic formula. So x equals the opposite of b plus or minus b squared minus 4 times a times c all over 2 times a. Let's see what we get in the square root. What? What? Quit that. I don't know who had that on my screen, but. Okay, I typed that in wrong. Times, that's a 1. What? Jolly Rancher. Thank you. Okay, I was right the first time, but by making several mistakes. You get the square root of -8. What does that tell you? There is no solution to that, so that means there are no x-intercepts. And then we get to the y-intercept. So we plug in f of 0. On the top, we have 0 plus 0 plus 3. On the bottom, we have 0 plus 2. So the y-intercept is 3/2. Okay, let's take a look at the graph and see what that looks like. We want to make sure that if we're using graphing calculator, we do need a parentheses about the top and the bottom. Okay. I'm going to zoom out a little so you can see the rest of it. Oh, let's see. How far do I have to zoom out? Okay, there we go. I have to zoom out quite a ways, but I hopefully can see that we would just want that -2 here. The graph is approaching it from both sides, but instead of like U's, they're kind of on this weird angle. Do you see that slant there? Okay, so we have something like this. It goes through 1.5. And then it kind of shoots off like that. And then it does the same thing going the other way. So I'm going to try to make it do the same thing going this way. So that would be a picture of my graph. The question I have for you is, this is its end behavior now, okay? And it's not a horizontal asymptote, but it's this slant asymptote. I don't know if I talked with you guys about that at all last year. And the way that you can find the slant asymptote is you can find it by synthetic division. So I'm going to pair this with how do you find other asymptotes, okay? So if I said, hey, what's the equation for that slanted line, okay? So if you're lucky, which we will be lucky, if you're lucky, we just use synthetic division, because can't we do synthetic division with the x plus 2? What would go in the box? Yeah, let's put -2 in the box. We're going to just do synthetic division with that expression. And I have my 1x squared minus my 2x plus my 3 there. So I have 1 times -2 is -2. -2 plus -2 is -4. -4 times -2 is 8. Okay. And this is my remainder, right? Okay, so what we do, because this is end behavior, the remainder is so little, when we get to the ends of the function, it doesn't matter. So we cross this off, and what we have left is the line x minus 4. And if I would graph the line x minus 4, you would see that it's the equation for this slant right here. So it's basically the division without the remainder in there, okay? And so while you're writing that down, I'm going to go ahead and plot it on here so you can see it. Oops, I just went back to the standard viewing window again, but okay. Can you see that in the back there? So you can see that slanted line. All right, so in my section about how you find other asymptotes, that's how you would do that, okay? I promised to you that something like this, I'll tell you, you'd have to use long division to do, and polynomial long division, so I'm not going to ask you to do that. But sometimes when you get asymptote, it's a slant, and I just want to show you a graph of another interesting one. If you would take an x cubed and divide it by an x minus 1, would that be an x? What would be the degree of that? If you took x to the third and you divided it by an x, what's the degree of that? X squared, like a parabola kind of thing? I want to show you something cool. All right, so would you do synthetic division with the x minus 1 a minute? So we have a 1, we have a 1, we have a -2. 3 plus -2 is 1. 1 times 1 is 1. Okay. So if I took my x cubed, remember I just divided by an x. This is 1x squared minus 2x plus 1. I'm going to cancel out that just because it's not going to matter when we're graphing the end behavior, okay? So I'm going to show you a picture of this graph and show you how this actually follows this parabola-shaped asymptote. Did you ever think that was a thing? Oops, I did a squared and then a thing. I didn't mean to do that. I'm going to go back to my standard viewing window and I'm going to take out my line from earlier. All right, so standard viewing window on these things, remember, is Zoom 6. I'm assuming you guys are using Decimus if you're not. Okay, so I get this weird kind of thing, and I'm going to show you what happens when I graph that parabola. What it's going to do is it's going to kind of loop right in here, and this part of the graph approaches it, and that part of the graph approaches it. So it was x squared minus 2x plus 1, and then you're going to see it come right around there. Weird. Am I going to ask you questions like that on your test? No, but I put a couple on your homework. It's interesting for some of us. It's interesting for some of us. Yeah, so that just describes its end behavior, but you can find them by using division. So there you go.